Good evening, and thank you for joining Meetly Omni's final presentation. Meetly Omni aims to enhance interaction during offline events and provide organizers with convenient event management tool. Today, we will cover 7 key topics: team introduction, infrastructure, sprint plan, tech stacks, features, future plans, and end with a Q&A session. Next page, please. Our project team consists of 7 developers, 7 DevOps, 1 business analyst, and 2 tutors who provide guidance in developer and DevOps. Next page. Let's welcome DevOps to introduce the architecture.
Hello, everyone. My name is Sean from the DevOps team. I will start by introducing our architecture to you all. First, we use Terraform to build and manage all our infrastructure resources, including AWS organization structure with IAM Identity Center, self-managed Jenkins agent on EC2 for CI/CD pipeline, front-end, back-end, and monitoring AWS resources. Then, we use Ansible to configure all EC2 instances. Our cloud-based UAT environment has already been deployed, and you can access it using uat.meetlyomni.com. Our front-end website is static and stored in an S3 bucket as the origin, using CloudFront as CDN, Route 53 as DNS, and AWS Certificate Manager to issue HTTPS security access. Our front-end website now interacts with the back-end service through api.uat.meetlyomni.com. An application load balancer is listening on port 443 of this API domain name and transfers traffic to an auto-scaling group with 2 EC2 instances. We have also created a RDS database in the same VPC, and a multi-AZ RDS will be deployed in the production environment for data backup as well. Next page, please. In addition, we also designed a set of EKS cluster, including completed infra as code, Kubernetes YAML files, and Helm chart. However, due to high cost, limited time, and low traffic, we haven't tested and deployed it yet. Next, let's welcome Peter to describe our CI/CD part. Next page.
Thank you, Sean. Hi, this is Peter. So for this project, we've decided to use Jenkins as our CI/CD pipeline of choice. The front-end setup is pretty straightforward, as you can see. We start from the bottom left of the diagram. So a merge triggers, a merge in the develop branch triggers the pipeline. Jenkins pipeline then reads the in file that's stored in Jenkins credential, which contains all the sensitive environment variable for the front end. It then builds the project and uploads it to our S3 bucket, which is configured for static web hosting. In the next slide, you will see our backend setup, which requires a bit more config and a few extra steps. Again, a merge triggers the pipeline. Jenkins grabs the end file, then builds a Docker image and pushes it to Amazon ECR. We then have an Ansible playbook as a stage in the pipeline, which pulls the image and deploys it in our backend EC2s, running the application in Docker. And here's where our team spent a good amount of time configuring and debugging the Ansible playbook, making sure that it's able to install all the necessary dependencies on the EC2s, run the container, and swap the images to deploy the newest version without any conflicts. And finally, just clean up the old images to free up the space on the EC2s. Now, to track the build outcomes, we incorporated a stage in the pipeline as well to send notifications to Discord. If the build fails, a detail log is attached in the Discord notification, and obviously we'll go back to the drawing board and figure out what went wrong. And personally, I think this is the core part of being a DevOps engineer, right? Getting firsthand insight into all the bugs and issues, allowing us to pull together the teams and work closely with them as a collective unit to troubleshoot these problems. And of course, if the build was successful, we don't just stop there. We continue to monitor the application to make sure it is running properly by using our monitoring setup to track the key metrics, which my teammate Zach will now walk you through in the next slide.
Thanks, Peter. Hi, I'm Zach. I will be presenting monitoring architecture we implemented to our backend services. Our primary focus was on monitoring the 4 golden signals: latency, traffic, errors, and saturation. Now, please look at the diagram on the left-hand side of the slide. We have node exporter at our backend EC2 to collect system metrics like CPU, memory, disk usage, and network traffic. Prometheus was set up on a separate EC2. It scraps metrics from node exporter at regular intervals. Grafana is also integrated with Prometheus to provide real-time visualization of our metrics. While Prometheus focuses on infrastructure metrics, we're also leveraging Grafana plugin to collect CrowdWatch metrics such as target response time, request count. We also configure alerts to notify us about anomalies or performance degradation by setting up an alert team through Discord to receive instant notifications when critical thresholds are breached, enabling faster incident response. And also, Terraform and Ansible were used to automate the provisioning and configuration of our monitor stack, making it easy to deploy and manage. The screenshots on the right-hand side are examples of the dashboards we've created on Grafana. With this monitoring setup in place of our project, we can proactively detect and resolve issues. And now I'll be handing back to the dev team. Thank you very much.
Thank you, Zach. Let me talk about our sprint plan. We have a sprint every 2 weeks, and we will organize a retrospective meeting after every sprint. And in our group, we have stand-up meeting every business day, and we use Jira as our project manage tool. Next page. Here's our last sprint, where you can track the progress of each part of the project. On the left side, you will see the backlog, while complete tasks are on the right. This helps us to stay organized and ensure everything is on the track. Next page. This is tech stack we use for the project. The front end is built with React, Vite, Tailwind Swift, CSS, and Shadcn UI using Redux and React Hook Form for state management. The backend is powered by .NET Core, PostgreSQL, RESTful APIs, and SignalR for real-time communication. For development, we used VS Code, Postman, Jenkins, Bitbucket for repo hosting, and Jira for project management. Next page, please. Our code base is hosted on Bitbucket, following the Git flow workflow for efficient branching and version control. Here are the features we're gonna discuss today. Let's start with company onboarding. This slide showcases the company registration process. The steps include entering an email, setting a password, and providing contact details. After registration, users can invite team members to join. Next page, please. We use .NET Identity for secure authentication, ACID transactions for data reliability, and RBAC to control API access, Docker Compose standardized development for seamless collaboration. We design a guided step-by-step form with real-time validation using TypeScript plus Salt. On the backend, we use Entity Framework for data integrity and Docker Compose for consistency, ensuring a balance of usability and security. Next page, please. The invite team member feature simplifies collaboration while ensuring security. Users can join either as a root user or via an invite. For invited user, a token is sent to validate their email address. handlebar templates enhance professionalism, providing a polished user experience. To ensure scalability, we plan to implement a pop-up message queue for reliable email delivery to multiple users. Next page, please. This is the team management dashboard where admin can invite members, assign roles, and manage access efficiently. Next page. Let's welcome Laura to introduce the game management.
Hello, I'm Laura. I walk you through the game management and question management parts. So after onboarding, users access the dashboard to manage events, games, teams, and statistics. To create a new event, users first create a game. In the game panel, they can view and manage all games based on their role permissions. By clicking Create and Edit, an input dialog pops up. We also pre-fill the information for editing. Each game has a master ID for versioning, and we use optimistic locking for conflict prevention. For images, users upload to our S3 bucket. The front prevents duplicate uploading using hash values, and the backend generates pre-signed URL for user access. Finally, by clicking Game Card, users will be guided to question page. Next, please. In the game part, on the left side, users can preview all questions in a sidebar. They can efficiently duplicate, edit, and reorder questions to manage their structures. In the main card, users can set up question titles, images, and answer options. They can also configure time limits, choose question types, and select background themes for each game. To enhance the user experience, we provide clear prompts when users delete a question, leaving the page without saving, or enter incorrect information based on game type, question types. In addition to front-end form validation, we implement custom validator for future game type expansion, such as raffle game. Using the factory design pattern, we dynamically generate validation rules, ensuring flexibility and scalability. Now, after setting up all the questions, users will be guided back to the main dashboard to manage their events. I'll handle this part to my teammates.
Hi everyone, I'm Quan, and I will walk you through the event management page. This page is similar to the game management page, but it goes beyond managing gaming events like quizzes and prize draws. It also supports game hosting. We have 4 key contest APIs. Auth contest handle JWT authentication and user data. Event context manage CIUD operation and filtered event list. Game context links events to games, and event dialog context controls the from state. State flows through this context to minimize post-drilling. For example, event filters updates filtered events, which trigger re-renders in the event list component. After user login, we auto-fetch events and games based on the company ID using a custom use request hook. This hook built on Exos that handles tokens, loading states, and errors. The central event dialog use React hook form with selected dropdowns, date picker, and real-time validation feedback for a smooth user experience. We ensure reliability through consistent UI with ShareCN components, instant feedback via toast notification, and backend unit tests using XUnit framework. That's all today from my side, and I will hand over to Christine.
Thank you, Quan. Next, I will briefly share how we implemented efficient user profile management and how it enhances the user experience. In our project, the main header across different pages will display the user's profile information, such as first name, last name, and profile icon. When users log in and click on the profile icon in the main header, and we can see a drop down on the PowerPoint, giving the quick access to key actions. In this drop down menu, we provide two main options. First one is account setting. Clicking this takes the users to the profile account setting page, where they can update their personal information and manage basic account details. And when we click log out, this logs the user out and redirect them back to the login page. This makes profile management not only accessible, but also intuitive. One key advantage is reusability. This profile component works across different pages, such as event management and game management, providing a consistent user experience wherever users go. Together, these features create a smooth, secure, and user-friendly profile management experience. That's all I have to share today about user profile management. I will pass it to Xiaobao.
Hello everyone, I'd like to talk about the game session. Starting with the host user view. Host user can click the host live games and then will redirect to waiting room page. Host user can start the game after all players join this room. And players can join the target room with unique access number, as well as can scan the QR code to join this target room. When ready to play, host user controls start game. Next, host user and all participants will redirect to countdown page. After countdown, all people in this room will receive the question. Each question has a timer. Host user only show question details, and players can submit the answer. Then after participants submitted the answer and the countdown done, host user click the show score to redirect to leaderboard page. The leaderboard page will update the score in real time. So we'll repeat for all questions. Finally, leaderboard information will broadcast to all players to show the final ranking. Signal R is real-time works. We use Signal R for real-time update, and in this game session, we ensure fair gameplay by validating answers and host control all process. We enhance engagement with live leaderboard, scan efficiency for multi-participants. Next part is our group member Edward to introduce. Thank you.
Thank you, Xiaobao. Now let me briefly cover the design of our landing page and our Swagger API documentation. Starting with the landing page, right underneath the navigation bar, we have a highlight message section, along with a brief description to showcase our core value as an interactive Q&A gaming platform. We've designed an intuitive user interface with two major entry points: create activity for organizers and join a game for participants, making it easy for everyone to get started. Next, our product features are displayed in the panel with 8 key capabilities, including team management, intelligent matching, game interaction, and real-time data analysis. Next page, please. To showcase how versatile it is, we present 4 major scenarios where it can be used, such as enterprise annual meetings, new product launching, team training, and community activities. Next page, please. The following sections include customer testimonials and frequently asked questions that address any concerns that our users might have in a real-world setting. So overall, with this layout, we aim to provide a smooth user experience while emphasizing our unique values. Next page, please. Now let's take a look at our Swagger API documentation, which not only helps with testing and consuming API endpoints, but also gives a clear overview of our backend system. There are 4 pieces of modules forming important parts of our backend, which are user authentication, events management, game interactions, and media storage. So under the auth endpoint, we have several post APIs to handle user authentication and account management. This includes registering both company and individual users, email verification, password resets, and sign-in functionality. These endpoints ensure secure and seamless access to our platform. Next, please. Next, we have the events endpoint, which provides CRUD operations, allowing event organizers to create, read, update, and delete events. There is a get events by company ID API to fetch all events associated with a specific company account. Again, endpoints plays a key role in our interactive Q&A feature. The routes here allow organizers to post and update questions for each game session, ensuring dynamic and real-time engagement for participants. Next, please. Finally, we have the S3 storage endpoints, which generates precise URLs with an object key. This ensures that events-related assets like images are easily stored and retrieved through AWS S3 buckets. That's pretty much it for my part. Now I'll hand it over to our team lead, Jess, to introduce future plans for improvement.
Thank you, Edward. So in the future, we plan to implement the price draw game and enhance our UI to be more responsive, and also enhance the front end and back end interaction. And also we wanted to implement the feature like reports and statistics, and also we will add more tests. Next, let's welcome Xiaobao to do a straightforward demo.
Firstly is company account register. Need to fill in company detail and user detail. After that, we'll receive verification email. When click verify, then we'll redirect to sign-in page. We can use company account to log in. Then login successful, we can use company account to invite other person. And select the target role, send the invite email. And the inviter need to check their email to verify their email. Then click successful will redirect to reset password. The user can use reset password to log in. Now is create game part. We need to type game title, game description, and upload image. Then we can create question. We can create single choice or multi-choice. Now I'm creating single choice. Need to finish all options and select correct answer. Then select save, and also can upload image. Now create event. We can select existing games. Just type event title, event description, and select the game type, access model, user limit, the time and the location, and select target game. We then create game event successfully. Host the user can live the game. Next part is game session. The first window is host the user view. Other three is participate view. After participate join the game, the host user can start game. Now is countdown page. All players will receive questions. Only participants can submit his answer. After countdown done, the host user will show the score page and repeat for all questions again. This event got 4 questions, so after finish, we'll direct it to final leaderboard page. Yeah, that's all. Thank you.
Thank you. That's the end of the presentation.